All right, welcome back to Calculus 2. We are going to continue talking about integrating rational functions. What I have now is the definite integral from 0 to 2 of x plus 1 over x squared plus 6x plus 8. First thing we got to do is we got to factor this bottom here. So we're looking at this and thinking, oh, it looks kind of like a proper fraction. The degree of the bottom is 2. The degree of the top is 1. So we have a regular fraction. So we can say this is going to be x plus 1 over, and here we have x plus, let's see, we have x plus 3, no, x plus 2, x plus 4. Okay, x plus 4. And we can go ahead and use partial fractions, okay, in order to break this thing apart. So we're going to say this is equal to a over x plus 2 plus b over x plus 4. And this is equal to x plus 1. That's what I have on the top, x plus 1. I'm going to use the cover method on this one. If you chose to use the equating coefficients method, it's not going to be too bad because you end up with a 2 by 2, and that's about the easiest thing you can solve. But let's go ahead and we'll say multiply everybody by our denominator. Okay, we'll do that first. Okay, so we can do that. So we're going to say we have a times x plus 4 plus b times x plus 2, and this is equal to x plus 1. Right? And that's what we have for this part right here. Great. Let's go ahead and set x equal to -4. That's going to get rid of this whole term. So we're going to have b times -4 plus 2 is equal to -4 plus 1. So we have -4 plus 2. That's going to be -2b is equal to -3. So we have b is equal to 3 over 2. I believe that's what I have for that one. It is. Okay. Got a kitty who's very insistent on being part of the production here. Next thing we're going to do is set x equal to -2, and we'll go ahead and figure out what a is. So we have a times -2 plus 4. Okay, that's going to give me 2. The b is going to disappear because -2 plus 2 is 0, of course, is equal to -2 plus 1. So we're going to say we have 2a, -2 plus 4 is equal to -1. A must be -1/2. Okay, so we've got this going on. So let's go ahead and figure out what we have. We have our A is equal to -1/2. So we want to integrate -1/2 times 1 over. Let's see here. We have our, what is it, x plus 2's? X plus 2's. Okay. Plus, and then our B was, what was our B? Our B was 3/2. We have 3/2 times 1 over, and this was, I believe, x plus 4. It sure is. Okay. And we're just going to integrate these pieces here. Okay. We're integrating the right-hand side. We replaced the right-hand side with this is our left-hand side. This is a much easier form to integrate, kind of like how integration by parts, we can integrate those parts instead of the original thing. So we could say this is going to be -1/2 times the natural log of x plus 2 plus 3/2 times the natural log of absolute value, x plus 4. And what were we integrating to? We were integrating between 0 to 2. Okay. So we can go ahead and plug these things in. So now we just have a mess of arithmetic, and we can go ahead and say this. We have -1/2 natural log of 2 plus 2 is 4 plus 3/2. 2 plus 4, we have natural log of 6 minus, okay, we're plugging in 0. So we have -1/2 natural log of 2 plus 3/2 times the natural log of 4. Let's go ahead and sort out some signs, SIGN signs. So we have -1/2 natural log of 4 plus 3/2 natural log of 6 plus 1/2 natural log of 2. All right. And then we have plus 3/2 natural log of 4. So there are some shenanigans we could pull with the natural logs. I'm not going to make you guys do this. Okay. The back of the book, you don't have a back of the book, but the back of my books would frequently feature shenanigans because people would do like, oh, 4 is really 2 squared. So that's the natural log of 2 squared, which is 2 natural log 2, and it would do a whole bunch of those things. But here we have a natural log of 4, 3/2 minus 1/2 natural log of 4. So we're going to have 2/2 natural log of 4, 2/2 better known as 1. So we have the natural log of 4. Here we have plus, let's see here, we have this guy here. We have, where am I looking at here? We have plus 1/2 natural log of 2. Okay. And then let's see, plus 3 halves. There's nothing I could really do with 3 halves natural log of 6. I'm sure it's a delightful number. That's just where we are with this piece here. Okay. And that would be my answer for this problem right here. And that's just fine. I promise you we will do a harder one next video, but we're going to call it a day for this one. And we'll see you in the next video. Thank you very much for watching and take care.